So this section's on the triangle midsegment theorem, and we want to start by looking at this particular triangle or pair of triangles and seeing what we notice about them. So what things do you notice about these two triangles, or this triangle with a segment in the middle of it? Looks like a triangle. We have parallel lines. DE has a slope of 0, 0 rise, right? Lots of run. And AC has a slope of 0. So we have parallel segments. What else? What else do we notice? Jacob. The triangle above looks double this, or the big triangle looks like it's double the size of the little one. Okay? Does that seem possible? Okay? How can we verify? How long is the pink segment? 4. How long is the purple segment? 8. So far, so good. Okay, the bottom segment of the big triangle is twice the size of the pink one of the little triangle. Okay? What else do we notice? It appears to be isosceles, so we should find out for sure, right? How long is this big segment? We're rising 1, 2, 3, 4, 5, 6, 7, 8 up, and 1, 2, 3, 4 over. So if we're making a right triangle, so we can use Pythagorean theorem. What is 4 squared? What's 8 squared? (16 plus 64 adds up to 80. How do we get rid of a squared? What's the opposite of squaring? Square root. 80 has a perfect square in it. 5 times what? And what's the square root of 16? 4 comes out, 5 stays in. Let's check the other one. Okay? Are we rising 4, rising 8, and running 4? Yep, so this one's the 4 square roots of 5. This one is 4 square roots of 5. Shall we check on the little one to see if it's half? Let's do it. Okay, we're going up 4 and over 2, right? That's half. So this is going to be what's half of 4 square roots of 5? 2 square roots of 5. 2 square roots of 5. In fact, anybody notice anything special about these points? Zero and 4. Half. 1, 9. First numbers are even, second ones are odd. The x's are evens, the y's are odd. But what happens if I take 1 plus 9 and divide by 2? Midpoint, right? So this is the midpoint of BA. Is this the midpoint? Is E the midpoint of BC? 4 plus 8 is 12. 12 divided by 6, or by 2? 6. 9 plus 1? 10. 10 divided by 2? It's a midpoint. Okay? So you found everything I think there is to find about it. Yes, sir? Absolutely. Could we use the distance formula instead of the midpoint formula? Absolutely. I'm sorry, the distance formula instead of the Pythagorean theorem, and the answer is absolutely. Okay? Now, those of you who are messing around, stop. Okay? Let's focus. Use your time. Okay? Let's not make this last longer than it needs to. Okay? All right, next. Same thing can happen with this next slide. Okay? I'm not going to take the time to do that, but can you find the midpoint of 2 points? Okay, to verify that they are in between and that you can find out that the slope, we're rising 3 and running 2. We're rising 3, running 2, rising 3, running 2. They have the same slope. Okay, so let's look and see what happens with this next piece. So in triangle RST, we want to show that the midsegment, which is segment MN, is parallel to segment RS, and that the distance between M and N is half of RS. So how are you going to do it? We won't take the time if we don't need to, but how will we do that? How do you show that they're parallel? Same slope, okay? So you're going to see how much am I rising, how much am I running? So what's my slope of MN? You should be jotting some of these things down. Okay, find the slope. Okay, when you want to show that they're parallel, you find the slope. Slope of RS, if you know it, then you don't have to write it. Just focus and pay attention. Okay, slope of RS, we're rising. Jimmy, no. We're rising 1, running 1, rising 1, running 1, rising 1, running 1. Slope of RS is also 1. Okay. How do we show that the distance between M and N is half of the distance between R and S? You guys remember the distance formula? You can use distance formula, or you can use Pythagorean theorem. I'm rising 1, 2, 3, 4, ran 4, so 4 squared plus 4 squared, 2 squared plus 2 squared. Pythagorean theorem or distance formula, your choice. Okay, does anybody need to see those worked out completely? All right, so here we go. So the midsegment of a triangle is something that was one of our extra ones that we had none of the above on Friday. When we saw that we had a point that went, if we went from the midpoint to the midpoint, it wasn't a median because it didn't go from C to the midpoint of the opposite side, from a vertex to a midpoint of the opposite side. The midsegment of a triangle is one that connects the midpoint of one side of the triangle to the midpoint of another. And we can actually have 3 midsegments, and they form a midsegment triangle. Okay, MP is the midsegment. It's parallel to AC, and it connects the midpoint of AB with BC. MN is also a midsegment because it's parallel to BC and connects the midpoint N with the midpoint M. And likewise, PN is also a midsegment. And the 3 together form a midsegment triangle. Questions so far? So midsegment means it's a segment that connects midpoints in a triangle. Make sense? All right. So here comes the next piece. Okay. The triangle midsegment theorem says that the segment that connects the midpoints of 2 sides and is parallel to the third side is also half as long as that side. But you recognized when we saw that earlier. Okay? DE is going to be parallel to AC, and because it's a midsegment, it's going to be half of AC. So we don't want to set these equal to each other, right? Because we have a small triangle that's proportional, it's similar to the large triangle, it's half as big as the whole one. So what will x's value be here? 44. Those are easy, right? You'll see that after we did all those proportions last chapter with all the similarity, we had a lot of math, a lot of algebra to do, not as much algebra in this chapter. All right, questions on this one? Midsegment is half of the base that it's parallel to. Okay, here's the hardest problem that you'll have to do today. Okay? This is what everybody wants to say. X plus 7 equals 6x minus 18. But is this as long as this one? No. What do we have to do? We have to take x plus 7 times 2 so that we can make them equal. We can do that, right? Or, Carson says, what if we just do half of this guy? Could we say 3x plus minus 9, as long as we divide each one by 2, is equal to x plus 7? Would that work? Yes. So if it's easily divided, you don't have to work with fractions, or even if you don't mind working with fractions or decimals, you can either divide the big one by 2 and set them equal, or you can multiply the midsegment by 2 and set them equal. Okay, do we need to work it out, or can you do it? Okay, so we're good? We're good? And we only had to find the value of x here. All right, last example. Okay, DE is the midsegment of triangle ABC. This guy's the midsegment. How would we find the distance between A and C? Multiply 4.8 times 2, because E is a midpoint, right? If DE is a midsegment, it connects the midpoints. So E is a midpoint. That means this is 4.8, this is 4.8. So what's 4.8 times 2? 9.6. That's the answer. Okay? We can do this stuff, right? All right. Assignment. Nope, one last thing. Okay? So here's how we use these in real life. Okay? Have you ever seen a house being built or a building being built? You've seen the trusses? Okay? That's a truss. And so they said that we use, obviously, triangles for strengthening in a roof. We want it to be able to handle problems with wind and problems with snow. All right, so in this diagram, UV and VW are both midsegments in triangle SRT. So we want to know what is the distance between U and V, this purple length. How long is it going to be? 45. Why 45? Half of the one it's parallel to, half of 90. Does everyone see that? Okay. And then VW is the red one. What's it going to be? Oh, it is 57. What does that mean? Times it by 2 and you'll have RS, won't you? So what's 57 times 2? 114. 114 will be the length of SR, or the distance between S and R. That's all we're doing. We can do this, right? Okay, assignment. We like midsegments.